Hello everyone, glad to see you. I'm Xu Zhenhai from Southeast University. My supervisor is Professor Gao Jianming. Today I will share my research with you. Deterioration of cement mortars partially immersed in sulfate. It's the content of my research. First, I will introduce the research background. With the development of economy in Salt Lake environment and marine environment, lots of concrete structures will be built. But in Salt Lake and marine environment, the sulfate content is very high. This will cause sulfate attack on concrete structure, and finally result in the insufficient durability. Many research found that the semi-immersed bridge revertment show more serious occlusion, especially at the draining part. So it's very important to study the deterioration of cement-based materials partially immersed in sulfate. Many research have investigated the occlusion mechanism of full immersed portion. They found that under the condition of full sulfate immersion, sulfate can diffuse into the interior of cement-based material and react with the hydration product, such as CH, CSH, C3A, to form AFT and gypsum, resulting in expansion and cracking. This is the most acceptable mechanism of chemical sulfate attack in full immersion. However, there are two main controversial about the mechanism of partial immersion. Many research think that concrete partially submerged in sulfate solution suffers from both chemical occlusion and physical attack. This is in accord with the field experiments that concrete partially immersed in sulfate suffers from surface scoring above the ground level. On the contrary, few researchers find that sodium sulfate crystallization can't occur in Portland cement concrete. Therefore, it's important work deeply investigating the deterioration driving force of cement-based materials partially immersed in sulfate solution. The second part is test method. We studied the effects of 5 factors on the erosion of cement-based materials. The cement mortars were put into the container after 28 days curving age. The 10 cm of the mortar are exposed in the air, and 6 cm are immersed in sulfate solution, and they were placed in different occlusion conditions. When reaching the set age, we test the various properties through different methods. The test method include mid-change, relevant diameter modulus of elasticity, and we use XRD to analyze the occlusion product, MIP to test the properties, and ICP to test the sulfate concentration. And we also use XCT to observe the cracking of the mortars. The second part is the results and discussion. First, we studied the effect of temperature on the occlusion of cement-based materials. The results show that the occlusion is the most serious under 35 centigrade. It's because that higher temperature causes higher chemical reaction and higher ion diffusion. But when temperature increases from 35 to 50, the solubility of sodium sulfate have improved. so the salt count saturates and crystallizes. The XRD results confirm the phenomenon. Moreover, the MIP shows that the property and connection of pools also reduce due to the non-crystallization of salt. Accordingly, mortar will not crack and corrode. We also studied the effect of RH on the occlusion of cement mortars. The results show that at high RH, ions mainly diffuse from immersed portion to draining portion and form high concentration sulfate, but the salt can't crystallize. So the occlusion of RH80 is serious than RH50, but at very low RH, ions accumulate due to capillary absorption, resulting in oversaturation and salt crystallization. Finally, the mortar can be damaged. The next factor is the concentration of sodium sulfate. We investigated 2%, 5%, and 10%. The XRD results show that high concentration of sodium sulfate will cause more serious chemical occlusion and salt crystallization, and lead to more occlusion product. Finally, increase the mid change and reduce the ERD. So higher concentration of salt solution will cause more serious sulfate erosion. We also studied the effect of mineral admixture on sulfate corrosion of cement mortar. The results show that the addition of fly ash and slag can improve the resistance of mortar under semi-immersed in sulfate. This is due to the continuous pozzolanic reaction between fly ash and slag, which reduce the poor connectivity and harmful pores of mortar, and reducing the ion transposition caused by capillary absorption. So the addition of mineral admixtures is beneficial for improving the sulfate resistance under cement immersion. The last factor is the water-to-cement ratio. We investigate 3 water-to-cement ratio and find higher water-to-cement ratio will improve the porosity and the pores connectivity, so the sulfate can easily transport to the interior of the materials. This leads to the more occlusion product, higher mass change and lower ERD. So higher water-cement ratio is harmful for sulfate resistance for mortar under cement immersion. Based on the above investigation, we get 5 conclusions. The first one, the occlusion is the most serious under 35 centigrade due to the high chemical reaction and high ion diffusion, but higher temperature will reduce the occlusion because of the improved solubility of sodium sulfate. The second is lower RH can lead to more serious occlusion than higher RH. At lower RH environment, the ions accumulate due to the capillary absorption, resulting in oversaturation and salt crystallization. Finally, the mortars be damaged. The next one is higher concentration of sodium sulfate will cause more serious chemical occlusion and salt crystallization and lead to more serious occlusion. The next one is fly ash and slag can improve the resistance of mortar under cement immersed in sulfate. This is because pozzolanic activity reduces the porosity of mortar. And the last one, is that higher water cement ratio improves the porosity and pours the connectivity, leading to more serious sulfate occlusion under cement immersion. That's all my report. Thanks for your attention. If you have any question, you can contact me through the email. Thank you. Bye bye.